Any problems are there regarding the display or voice issues, you can call at the helpline number which is being displayed at the bottom of the screen. Okay, so shall I start? So today's the test which I am going to discuss is regarding removable prosthodontics, including the dental materials part of it. Okay. So the first question is, in cold cure resin, the activator is. The correct answer for this is the second option, which is dimethyl paratoluidine, which is a tertiary amine. Okay. So in a cold cure resin, there is an activator initiator system. The initiator is the benzoyl peroxide and activator is dimethyl paratoluidine. So when both the powder and the liquid are mixed, it's okay. So when the powder and the liquid are mixed, the initiator releases free radicals, which causes the polymerization reaction to start. The other questions which can be asked regarding this topic is that the dibutyl phthalate, which is also a component that acts as a plasticizer. Then regarding glycol dimethacrylate, which is a cross-linking agent. So the thing to be noted over here is that the glycol dimethacrylate possesses 2 double bonds per molecule, while the methyl methacrylate monomer has single bond per molecule. So this can also be asked as a question, and this is present in the liquid component. Then the inhibitor which is present in a cold cure resin system is a hydroquinone, which prevents unnecessary polymerization during the storage. So the hydroquinone acts as an inhibitor. Similarly, they can ask you question regarding light cure resins also. So in this, the activator initiator system consists of a photosensitizer. The photosensitizer is commonly used, which is camphoroquinone. And the initiator is dimethyl aminoethyl methacrylate. Okay, the activator initiator system in the case of light cured resins is a photosensitizer, which is camphoroquinone, and the amine initiator is dimethyl aminoethyl methacrylate. So we are done with the first question. Do you have any doubts regarding this question? Should I move on to the next question? Okay, I'll move on to the next question. The anti-flux material are all except. The correct answer is fluoride, which is option number 4. So the first 3 options, graphite, iron oxide and calcium carbonate in alcohol, all 3 are used as an anti-flux, while fluoride cannot be used as an anti-flux material. fluoride is a flux. So what is an anti-flux? Anti-flux is a material that confines the flow of solder or solder attachment flow. The significance of anti-flux is to help confine the solder to the required area. So it helps us in maintaining the proper connector shape and thickness. So it is used before the application of flux. The types of anti-fluxes which are used are graphite, which is commonly present in the lead pencil. So we just mark, we use lead pencil and mark that area in which we want the solder joint. Another example of anti-flux is iron oxide in chloroform. And another example is calcium carbonate in alcohol and water. So fluoride flux, which is given as a fourth option, is a flux. It is not an anti-flux. So now we'll also look at the types of fluxes, which can also be asked as a question. So that fluxes can be classified on the basis of their application. Fluxes which are used for noble metal alloys are based on borate, and fluxes which are used for base metal alloys are based on fluoride systems. And based on use, the fluxes can be classified into type 1, type 2 and type 3. So the type 1 is for surface protection, which is used for noble metal. Type 2 is for reducing agent, so that the metal oxides which noble metal forms, so they can reduce those metal oxides. And the type 3 is a solvent which is used for base metal. So base metal alloys like nickel chromium, cobalt chromium, they form very strong oxides. So for a proper solder joint, we need those oxides to be removed first, or a solvent which can remove those oxides. So the type 3 type of fluxes, the fluoride fluxes, are used for base metal alloys, while the borate fluxes are used for noble metal alloys. Any doubts regarding this question? I'll move on to the next question. Okay, I'll wait for some more time. Should I move on to the next question now? Okay, I'll move on to the next question. The third question is, in acrylic resin denture, true is. The correct option is for each 1% increase in weight by water, absorption produces 0.23% linear expansion. So for every 1% increase in weight by water absorption, there is a linear expansion of 0.23%. Since this is a value based question, you just have to memorize it. There is nothing to explain in this. Still, if you have any doubts, please you can ask me. I'll move on to the next question. Direct coupling or by the exchange of hydrogen atom from one growing chain to another in a polymerization chain reaction is termed as. I'll repeat the question. Direct coupling or by the exchange of a hydrogen atom from one growing chain to another in a polymerization chain reaction is termed as. The correct option for this is termination. So the stages involved in a polymerization reaction are initiation, propagation, chain transfer and termination. So the termination can result either from an exchange of a hydrogen atom from one growing chain to another or by direct coupling. The first option, introduction, is not a stage in polymerization. The stages are initiation, propagation, chain transfer and termination. Any doubts regarding this question? I'll move on to the next question. Okay, so the next question is addition of 2% potassium sulfate and 0.5% borax to agar-agar helps in. The correct answer for this is it helps in regulating setting time and expansion of plaster. Addition of 2% potassium sulfate and 0.5% borax to agar-agar helps in regulating setting time and expansion of plaster. So now we'll have a brief look about the composition of agar-agar. So in agar-agar, the basic component which is agar is 13 to 17%, which is the basic component. It forms the brush heap structure. The second component is the borate, the quantity of which is 0.2 to 0.5%. It strengthens the gel and retards the setting of impression material. So to counteract this retarding effect of borates and to ensure proper setting of the cast, we have to add potassium sulfate, the quantity of which is 1 to 2%. Then wax is added as a filler, and thixotropic material, which is 0.3 to 0.5%. Then the remaining amount is water, which is a dispersion medium. Any queries regarding this question? It's a straightforward question, I guess. Okay. So the next question is the flow of type 1 impression compound at 37 degrees centigrade is. The correct answer is 6%. The flow of type 1 impression compound at 37 degrees centigrade is 6%. This is also a value based question. You have to just mug it up. So now we will see the other values regarding the type 1 and type 2 impression compound. So the type 1 shall be suited for taking impressions in the oral cavity, which is a low fusing type, or commonly known as the green stick. And type 2, which we commonly know as impression compound, it is also called as tray compound. It is used for recording primary impression or forming trays to be used in the oral cavity. So regarding the flow for type 1 compound, which is the green stick or the low fusing, the flow at 37 degrees centigrade should be no more than 6%, which is the question asked over here. While the flow at 45 degrees centigrade should not be less than 85%. Otherwise, we won't be able to record the details in the oral cavity. So the flow for type 2 compound, which is more rigid, should not be more than 2% at 37 degrees centigrade. And at 45 degrees centigrade, it should not be less than 70%, nor 85%. So any doubts regarding this question? I'll move on to the next question. Okay. So the next question, question number 7, is what is the C factor in a dental material? So the C factor is related to polymerization shrinkage which occurs in composites. Which is the third option. So now we'll see what is the C factor in detail. So the C factor is a ratio of bonded surface to the unbonded surface in a cavity preparation for composite. So for example, for a class 1 restoration, the bonded surfaces, let's count the bonded surfaces for a class 1 cavity. So for a class 1 cavity, the bonded surfaces would be the pulpal floor, then the mesial wall, the distal wall, the buccal wall, the lingual wall. So in total we have 5 bonded surfaces and 1 unbonded surface which is facing towards the occlusal surface. So the ratio comes out to be 5. So the C factor for class 1 restoration is 5. So the higher the value of C factor, the greater is the potential for bond disruption due to polymerization shrinkage. So we should always try to achieve the lowest possible C factor. How do we achieve this? Can anyone tell me how do we achieve to reduce the C factor? What measures can we take to reduce the C factor? Can anyone tell me? Yeah, incremental curing is the right answer. So by incremental curing, the C factor is reduced. So considerably the polymerization shrinkage is also reduced. So this question is clear to all of you? Okay, so let's move on to the next question. Which of the following impression material is easy to pour and difficult to remove the stone cast from the impression? So the correct answer for this question is polyether. The reason being, polyether is a very stiff impression material. So out of all the rubber based impression materials, polyether is the most stiff impression material. So when we try to retrieve a cast from the impression, there are chances of breakage of the cast because of the rigidity of the polyether impression material. So other important points which should be remembered regarding polyether impression material, and these can also be asked as an MCQ question, that polyether is a hydrophilic impression material like your hydrocolloids. All others like polyvinyl siloxane and condensation silicones, all are hydrophobic impression materials, while polyether and hydrocolloids are hydrophilic impression materials. Then another point which can be asked is that polyether has the highest cell toxicity. So it is the least biocompatible of all the silicon impression and the rubber base impression materials. Also, polyether was the first elastomer to be developed as an impression material. Okay. Any doubts regarding this question? I'll move on to the next question. Okay, last point I'll repeat. Polyether was the first elastomer to be used as an impression material in the oral cavity. The first elastomer to be used for dental impression purpose was polyether. Okay, now I'll move on to the next question. Okay, one more point regarding polyether. That polyether is also the material of choice for multiple implant impressions. It can be asked as a MCQ. Polyether is a material of choice for multiple implant impressions, because when multiple implants are involved, we want an impression material which is very rigid. So because of the increased stiffness and rigidity, polyether is a good choice for multiple implant impressions. Also, you can see the stiffness in the increasing order is as follows, from the lowest to the highest. The least is polysulfide, then is the condensation silicon, then is the addition silicon, and the highest stiffness is of polyether. So the ninth question, the next question, clogging of an abrasive wheel with debris causing reduction of abrasive action is called as blinding. Yeah, you must have experienced it while we are using an acrylic trimming burr, like a metal trimming burr. The acrylic which is getting trimmed, it blocks the flutes of the burr which you are using. So it reduces the trimming efficiency or the cutting efficiency of the abrasive. So this is called as blinding. Buffing is used to polish a denture. Other two are not correct options. There is nothing called as truing. It's just a fake option. There is nothing called as truing. It's just This truing is just given to confuse you. There is nothing called as truing. The third and the fourth options are given just to confuse you. It has nothing to do with an abrasive action. Okay. Buffing is a process which is used for polishing of dentures. After you have used your sandpaper mandarin for finishing of the denture, the final process of polishing involves buffing on a ragged wheel. So it gives a polish or a finish to the denture. That is called buffing. The other two terms, dressing and truing, are not related to abrasive action. Okay, the next question, the 10th question. In a visible light cure denture based resin, camphoroquinone serves as the initiator. This we have already discussed in the previous question. I have covered the light cured part also in the question which was asked on the cold cure resin. So the camphoroquinone acts as an initiator in a visible light cure denture based system, or even for that matter composite. Okay, the next question, the 11th question. All of the following components are present in the liquid composition of heat cure acrylic resin except the correct answer is NN dihydroxyethyl paratoluidine. So this fourth option, dihydroxyethyl paratoluidine, is a component of a cold cure resin system, which is an activator. But for heat cure acrylic resin, the activator is heat itself. So heat acts as an activator. So this, the fourth option, it is not present in a heat cure acrylic resin system. I'll move on to the next question. Should I move on to the next question? So the next question is question number 12. What is incorporated in porcelain during firing? The correct option is helium gas. Why? Because helium is a gas with low molecular weight, which is introduced to the furnace at low pressure during sintering stage or the densification stage. So later on, when the pressure is increased towards the end of the firing cycle, due to its low molecular weight, it is squeezed out or diffuses out under the pressure of shrinking porcelain. So because of the low molecular weight of helium, it is preferred and it is introduced into the firing furnace, because if air gets entrapped, it will be entrapped and it will cause porosity in the porcelain, which we do not want. So helium occupies the interstitial spaces and can easily be removed when the porcelain is polymerizing, when the porcelain shrinkage is occurring, sorry. Okay, I'll repeat the question. What is incorporated in porcelain during firing? What is incorporated in porcelain during firing? So the correct option is helium. So the text says only about helium. I don't know about any other gases which can be introduced during the firing process. Okay, the next question now. So the boiling point and melting point of methyl methacrylate, the option is, correct option is 100.8 degrees centigrade is the boiling point and melting point is minus 48 degrees centigrade. This is also a value based question. No explanation I think is required for this. So curing cycle, let's have a look at the curing cycle, which can also be asked since it is related to the topic. There are three types of curing cycles. First is 74 degrees centigrade for 8 hours. The second curing cycle is first 74 degrees centigrade for 8 hours, then increase the temperature to 100 degrees centigrade for 1 hour. And the third curing cycle is heating at 74 degrees centigrade for 2 hours and increase the temperature to 100 degrees centigrade and process for an hour. So these are three types of curing cycle. So the next question, question number 14. Tempering of reversible hydrocolloid is done for. The correct option is 3 to 10 minutes. Tempering of reversible hydrocolloid is done for 3 to 10 minutes. Tempering means reduction of the temperature, tempering means reduction of the temperature before introducing the impression material to the oral cavity. So the agar impression material manipulation involves the following steps. First is the boiling. So the temperature in the boiling bath is around 100 degrees centigrade. Then the second bath is the storing bath. The temperature in the storing bath is nearly 65 degrees centigrade. And the tampering bath, which is in which the impression material is tampered before introducing into the oral cavity, it is less than 55 degrees centigrade, mostly around 45 degrees centigrade. Regarding this, they can also ask you a question regarding laminate technique of impression material. Laminate technique, in which both agar and alginate are being used. Tampering means reduction of the temperature so that it does not burn the oral cavity. Like when we use impression compound also, we heat the impression compound in the flame and then we tamper it in hot water. Similarly for agar, the storing bath temperature is 65 degrees centigrade, which is too high. So before introducing in the oral cavity, we need to tamper it to 45 to 55 degrees centigrades. That is called tampering. So other important points regarding hydrocolloid impression material: they possess syneresis and imbibition, which is absorption of water and loss of water. The hysteresis, which is the lag present between the syneresis and imbibition. Agar impression material needs water-cooled trays for impression. And laminate technique I just told you about. Then agar is also used as a duplicating material. When we need a refractory cast for a cast partial denture, agar is used as a duplicating material. I'll move on to the next question. All the following are accelerator that enhance the setting reaction of gypsum except. The answer is sodium chloride less than 20%. All the following are accelerator that enhances setting reaction of gypsum except sodium chloride in a concentration less than 20%. This act as a retarder. All others, gypsum less than 20%, potassium sulfate and sodium chloride less than 20%, less than 28%, sorry, are accelerators. So gypsum less than 20%, potassium sulfate Sodium chloride less than 28%. All these are accelerators. So a question can also be asked on slurry water. Slurry water is a water which is mixed with the excess. Sometimes when you mix stone or plaster, some amount of remaining stone or plaster which was there from the last time, it is sticking onto the impression bowl in your mixing bowl. So when you add water to that, it acts as a slurry water. So that also can be used as an accelerator. Now we'll also have a look at the retarders which can be used in gypsum products. So retarders generally act by forming an adsorbed layer on the hemihydrates to reduce its solubility and on the gypsum crystals present to inhibit growth. So the commonly used retarders are glue, gelatin and some gums. Another type of retarder which consists of salts that form a layer of calcium that is less soluble than the sulfate. These include borax, potassium citrate and sodium chloride 20% or less. I'll move on to the next question. Supercooled liquids are solids displaying atomic arrangement of a typical liquid. Supercooled liquids are, the correct option is solids displaying atomic arrangement typical of liquid. So the example for a supercooled liquid is glass. Because glass is a non-crystalline solid, the ordered arrangement of glass is more or less locally interspersed with considerable number of disordered units, and this arrangement is very typical of liquids. So such solids are sometimes called as supercooled liquids. So supercooled liquids and like amorphous substances, they have a glass transition temperature which means they do not have a definite boiling or a definite melting point. So they have a glass transition temperature instead of a definite melting point. All the crystalline substances or crystalline solids, they have a definite boiling point and a definite melting point. While amorphous substances and supercooled liquids like glass, they have a glass transition temperature and they do not have a definite boiling or a melting point. So now the next question, question number 17. Adhesion. The correct option about adhesion is option number 1. When involves primary bonding is termed chemisorption. So the second option, which says enhanced by presence of small amounts of impurities, adhesion is inhibited by small amounts of impurities. It is never enhanced. And adhesion is reduced if surface energy is reduced. It is not increased if surface energy is reduced. So surface energy is directly proportional to the adhesion. So the only correct option over here is option number 1, which involves, when primary bonding, it is termed as chemisorption. So in chemisorption, a chemical bond is formed between the adhesive and the adherent, and greater the surface energy, greater is the capacity for adhesion. Example, adhesion in an oxide film formed on the surface of a metal or a layer of a solder bonded to a metallic substrate. So whenever there is a chemical bond formed between the adhesive and the adherent, it is called as chemisorption. I'll move on to the next question. The tendency for a liquid to spread over a solid increases as. The correct option for this is option number 3, as the contact angle decreases. So whenever the contact angle is less, the tendency for a liquid to spread increases. So the next question, question number 19. Plaster of Paris, resin cements, certain impression materials are known to behave as. The correct option is thixotropic fluids. So let's have a look at the different kinds of rheological properties like Newtonian fluids, dilatant fluids and pseudoplastic fluids. So first, the Newtonian fluids, their viscosity is always constant. They do not have any effect of pressure on viscosity. So the viscosity of Newtonian liquids is always constant. There is no effect of strain or pressure on the viscosity of Newtonian liquids. On the other hand, for dilatant liquids, viscosity increases on application of pressure. And the pseudoplastic liquids, the viscosity decreases on application of pressure or strain. So the example for thixotropic materials is profile axis paste, plaster of Paris, resin cements and some of impression materials. So on application of pressure, the viscosity decreases. So I'll move on to the next question. In Bezold-Brook effect, the apparent color of an object. Correct option is viewed under dim light changes as the brightness is intensified. In Bezold-Brook effect, the apparent color of an object viewed under dim light changes as the brightness is intensified. At low light levels, the rods of human eye are more dominant than the cones, and the color perception is lost because rods are only sensitive to dim light. The cells in retina responsible for the color vision is only the cones. So as the brightness becomes too intense, color appears to change. So this effect is called as Bezold-Brook effect. Also, if an observer looks at the red object for a reasonably long time, the receptor fatigue causes green hue to be seen when the observer then look at the white background. That is why when a patient is observed against an intense colored background, the dentist might select a tooth shade with a hue that is shifted towards the complementary color of the background. Then something which is also related to this effect, they can ask a question regarding metamerism, which is appearance of a color, two different colors under two different lighting conditions. So this effect is called metamerism. Now I'll move on to the next question. Elastic modulus of enamel is 3 times greater than that of dentine. This statement signifies that enamel shows less plastic deformation. Elastic modulus of enamel is 3 times greater than that of dentine. The correct option for this is enamel shows less plastic deformation.